Okay guys, so moving forward in your percents chapter, I want to take a look now at the percent strength of solutions. If you're following along in your book, you may notice that the next section is called percent change. I'm going to go ahead and skip that as I don't have any questions on next week's test on percent change, so you don't need to worry at all about that. Let's go ahead and let's just move forward to the percent strength of solutions. So in your text, the first part of that section looks like this, what you have on your screen here. It mentions to us that anytime we're dealing with any solution of any sort, whether it's a medication or whatever it might be, even peroxide is a percent strength. It tells you on the side of the bottle, if anybody's ever seen peroxide or alcohol, it tells you that it's 91%, or peroxide I think is like 5% or 0.5% or something like that. They're percentages to tell you how concentrated they are. What has happened, and again what you guys can see on your screen is that solute there. We've taken some type of pure substance, we've added it into some liquid of some sort, and then that comes out to then be that solution, that mixture. It's like getting a better visual. It would be like taking sugar, taking a spoon and put it into water, and when you mix that up, we now have a solution of sugar water. So sugar is a solute, water is the solvent, and that now gives us the solution. And that's what we're looking at here, is how, to interpret what that means in terms of those percentages and what we want to do math-wise with these, I should say. So it mentions too that what's going to happen in these solutions, the solute is going to be measured in grams, and then the solvent will be measured in milliliters. And that will then tell us our relationship. You don't have to worry about, what's going to happen there. Let me show you what this represents. So in an example, so moving forward in your text, they do give us an example that says, well, that means if I have a 15% drug solution, that means that we have 15 parts of that drug, and it's been diluted into 100 parts of a solution, which makes sense because remember, anytime we're dealing with any type of percentage, as we talked about in the first video, percents always represent something out of 100. If I got a 15% on a test, that means I got 15 points out of a total of 100 possible points. And I know in the last section we talked about that there may not have been 100 questions on the test, but that's what that represents. Anytime we have a percent solution, or a percent of anything, that's what that represents. It's represented out of 100. So that's where they're showing us here that means 15% is 15 out of 100. And reduced, we know that when we reduce fractions, we can, divide them both by the same thing. They show us there that both 15 and 100 can both be divided by 5. They show it in kind of a different way in your text, but they can divide them both by 5, and therefore our reduced fraction, our reduced relationship there, so a ratio is, the same thing there, is a 3:20 solution. So anytime you're given a percent solution, I may ask you that. What does that mean in terms of grams per milliliter? Well, if I have let's say a 6% solution, that means there are 6 grams to every 100 milliliters. And let me just write the units there. 6 grams for every 100 milliliters based on, again, the fact that it's a 6%. And then we want to always make sure that we reduce it. 6 and 100 can both be divided by the same thing. We can divide them both by 2. When I do so, that gets us down to a 3:50 solution. So that's our reduced version of that. If I gave you let's say a 20% solution, then that means, as far as our relationship right now, that we have 20 grams to every 100 milliliters. But again, because 20 and 100 can be simplified, I can divide those both by 5. We can go ahead and take a look at what that would be if we divided them both by 5. Well, 20 divided by 5 gives me 4. 100 divided by 5 gives me 20. But looking at this now, it looks like I can take that a step further because I can divide those both by 4. And I end up getting a 1:5 ratio on that. So 1:5 solution is what that would reduce to. And yes, we could have reduced the 20 and the 100 at the very beginning by 20, and that would have taken us down to the same thing. Let me show you how some of these means. So going back to what we just saw on the previous screen here. So yes, I know that if I have a 6% solution, so let me just remove that. If I have a 6% solution, that means that in this drug, in this diluted medication, I have 6 grams for every 100 milliliters. But what we can also do with these percent solutions is if I ask, perhaps, well, maybe the doctor doesn't want to give a patient 100 milliliters. Maybe they don't need that full 6 grams. I can figure out how many grams it would take if I was given a new amount based on using this as a known. So on the next screen, I'm going to show you guys how will be worded. One thing I want to show you before I show you that. So what that a proportion using a known and an unknown. So this is what we talked about in the lectures last week. That understanding that if I have an 8% solution, for instance, that I know what that represents in terms of grams per milliliter. But if for some reason the doctor doesn't want to give 100 milliliters, if we want to reduce that, we can figure out how many grams that would take in order to create that solution. So on the screen, you're looking at an 8% strength. 8% means that I have 8 grams of drug to every 100 milliliters. And so we can look at that by what I've drawn on the screen there, 8 grams to every 100 milliliters. And let's say if the doctor orders only 25 milliliters of that same percent strength, I want to know how many grams I would need in order to create that lesser amount of medication, but keep it at an 8% solution. So what we can do is we can represent that 8 out of 100 as a known. And just like we've seen with those proportions before, if I set that equal to, as they've shown over here on the right, that if I set that equal to x over 25, then just how we know how to reduce, not reduce, but to solve all proportions, as we're very familiar with proportions, I cross multiply 8 times 25. We know 8 times 25 would give us 200, and then I take that and divide, and they're showing us in these steps right here. 8 times 25 would give us 200, and then 200 divided by 100 gives us 2. So that means we would need only 2 grams in order to create that lesser amount of solution. And so let me show you how these questions will be worded. So I may ask you a series of questions about these percent strength solutions. What I will give to you is I will give you a percent concentration. So this is the example in your text on the practice 10. And those examples, this is example number 3. I went with example number 3 because it's the only one of the 3 in your text that utilizes a whole number. And on your all's quiz next week, when that opens up, you guys will see that I will only use a whole number on these types of percent solutions. I don't want you guys to worry about having to deal with fractions or decimals and percent solutions, as those can be a little bit more complex. So I want to work with the one that's a whole number. So what I'll do is I'll give you a percent strength solution, and then I will ask you a series of questions about that same percent strength. So looking at the one we have on the screen, a 78% strength solution has been prepared. First question says, how many grams of medication are in this 78% strength? The second question says, how many milliliters? So what those two questions are actually asking us is based on what we know about these percent solutions. So far, everything we've looked at so far, if I have a 78% strength, remember what that means is that we have 78 grams for every 100 milliliters of that solution. Questions A and B are asking me simply just that. I want to know, letter A, how many grams? The answer would be 78 grams. Sorry, my handwriting's terrible there. 78 grams. Letter B says how many milliliters are in this 78% strength. Again, just based on the known, 100 milliliters. So that's what I'm looking for on questions A and B. And it won't be on your all's quiz next week. These will be separate questions so that you can get a point apiece for each of these. So I would say a 78% strength solution has been prepared. How many grams of medication are in the 78% strength solution? So that would be maybe number 1. Then I would give you the same statement. In number 2, I would start with this same statement. A 78% strength solution has been prepared. But number 2 would say then how many milliliters are in this solution. Number 3, I would start with that exact same statement again. I would start with the 78% to keep reminding you what that solution is. But then letter 3 will say, well, let's express that as a simplified ratio. And that's based on that reduction. Remember, we can reduce these, both 78 and 100. I know I can divide by, say, 2. So let's say we do that, 78 and 100. I know for sure they're both even, so I know I can divide those both by 2. When I do so, 78 divided by 2 is 39, and 100 divided by 2 is 50. Because I can't reduce 39 and 50 any further than that, 39 and 50 both can't be divided by the same thing, so I am going to go ahead and leave it at that, and that is our simplified ratio. So I'll write it next to question 3. And whether or not you write that as a ratio or a fraction, I will go back in and override that if the computer marks you wrong for any reason, but I have that set up there to where it would take both. So just FYI on that. Now, letters D, E, and F are based on exactly what we just talked about with those proportions. What's going to happen is all three of those, D, E, and F, or the next question on your quiz, would be based on the same percentage you're working with. So based on whatever percentage is given to you, I want to use that as my known. And then now I want to know if maybe I want to make a different amount of that solution, how many grams would I need? So for instance, there in letter D, it says how much pure drug is needed to create 65.5 milliliters of the solution. So in other words, let's think about it this way. Okay, so I'm going to write this down at the bottom. I know that there are 78 grams for every 100 milliliters in this percent strength. What I want to know is how many grams would I need to make 65.5 milliliters. So using that as my proportion, again, I've got it set up where it's, known on one side, unknown on the other. I've got grams on top of both, milliliters on the bottom of both, so I know that my units have matched up. All I need to do is cross multiply and divide. So if I cross multiply 65.5 times 78, I get 5,109, but then taking that and divided by 100 should give me 51.09. So I know on that letter D it says round to the nearest tenth, but totally up to you if you do that or not. But that means we need 51.09 grams or 51.1. However you choose to round that is totally up to you. I will make sure that that gets counted when I go in and grade those quizzes. And letter E asked the exact same question. Letter E said how much pure drug is needed to now create 90 milliliters. So I'm going to write this one here in red. So once again, our known is 78 grams to 100 milliliters. And guys, you can also use the simplified ratio here if you want to. 78 to 100 is the exact same thing to 39 to 50. I'm always just in the habit of using the percentage that I have in front of me, so I just take that 78 and 100. But again, 39 and 50 is just a reduced version of the same fraction, so you very well could use that if you wanted to. But continuing on with letter E, there's my known. My unknown, based on this question, I need to create 90 milliliters, so I set that up as X amount of grams over 90 milliliters. And so that is the proportion that I will use in this case. So I'll take that 78 and multiply it by 90, and that will give me 7,020. Dividing that by 100 would give me 70.2. So I'm going to go ahead and write that in red next to letter E, 70.2. So you can see letters D, E, and F, I'm actually just doing the same thing in each of these. I'm just, again, we're creating a different amount. So I want to know, again, based on what I know about this percent solution, I want to keep it at the same concentration. So I want to know how many grams would I need to create that. So in letter F, finally down there, again, my known is still the same. It's the same percent solution here. And I want to know how many grams would I need now to make a much bigger amount, but we still set it up the exact same way. 78 over 100, I set that equal to X over 450. When I go to cross multiply 78 times 450, I get 35,100. So when I divide that by 100, that's going to give me 351. So I'm going to write that here in green next to letter F, that would be 351 grams. So that's what you guys will see with these questions about percent solution. I may simply just ask you, so let me remove all this stuff here. I may simply just ask you, okay, well, how many grams are in that percent strength solution. Let's imagine even if this was a 6% solution. Well, we've already seen a 6% solution, haven't we? So let's just imagine just something smaller. Let's say this was an 8% solution. So imagining that, then the answer to letter A would be 8. Letter B would still be 100, right? Because the first two questions there, how many grams and how many milliliters are just in this percent strength solution. Again, we're imagining that it's an 8% solution. That's based on that definition of what we know about this. Expressing that as a simplified ratio would mean that we just simply need to reduce it. Both 8 and 100 I can divide by 4. So if I divide these both by 4, we would get 8 divided by 4 is 2. 100 divided by 4 is 25. I can't reduce 2 to 25, so a simplified ratio would be just that, 2 to 25 in an 8% solution. And then letters D, E, and F are exactly what we did in the previous examples with that 78% strength. Letter D, my known is 8 to 100 because it's 8 grams for every 100 milliliters. I instead just want to know how many grams do I need to create now 65.5 milliliters. So it'd still be set up the exact same way, just a different known. And keep in mind, again, you can use that known, based on what we know about an 8% strength, that's a G, an 8% strength, or you can always use the reduced simplified version. You can use the 2 to 25 in this case if that's easier, but again, they both represent the same fraction. So I just wanted to show you guys that's what we will see in terms of the percent strength of solutions. So I hope that helps with that. You'll see a series of questions with that, and you'll see some of those on the homework. If you guys have any questions, let me know.